topic is also being part of identity. He strongly believes that openness and honesty are core traits of housekeeping. To share some insights about computer-generated randomness and how random that randomness really is. Rafał.
Welcome to my presentation. Thank you for coming. I'm kind of guy that likes to dig into this obvious stuff. Last year I was presenting some facts about hashing functions, and this year I would like to go into another obvious thing, which is random numbers in computers, which may seem pretty easy and pretty obvious, but as I hope you'll see, it's not that easy. Short agenda for today. First, I will go through some introduction, non-technical one. Then we'll go shortly to the history, how the random numbers were treated and presented in the past. Then we'll go to the random number generator. So the main focus on this presentation, how they are generated and what tools and mathematical functions are used to get them. And then we'll go to the examples where they are used and how they are used. Then I'll show some, let's say, fails when the usage of random numbers wasn't correct, and the repercussions of this were immense. And then some takeaways. So first, what do you think is random? What are our thoughts when we are thinking that something is random? Is weather random? Maybe when we are observing the changes of the weather, we think they are random, but we don't know what are the rules that weather is changing. There are people that are trained to predict weather, but they are also not so sure. Is road traffic random? People are coming and transporting by cars, but maybe there are some rules that are leading people to go out of the office, for example, in workdays, or go for the longer weekend for vacation. What are the difference between random generated by hand, by people, or the randomness generated by the computer? In both topics, we have to do some action. For example, if we are rolling a die, we have to roll a die. If you are generating number by computer, for example, rolling a virtual die, you have to press a button and it's die. What are the chances of each number where they are equal? If the die is fair, so it's 1 over 6. In the computer-generated number, it's also equal. But what about the predictability? The physical dice, we can't really predict what will be the roll. There's 1 over 6 chance that we'll get a number, but each die is independent. Each roll is independent. We can't predict what will be the next. But in the case of virtual numbers, it's not always the case. As we will see, the methods used for generating numbers aren't unpredictable and may be used to do some damages. I think we know subconsciously what is a randomness. It's chaos, it's lack of patterns, it's lack of predictability in events. It's something out of our control which we can't predict. And in the past, it was used as a tool of some kind of, people believe that some things just happen. There is no rhyme and reason to them. Some believe that this was like a divine intervention. Also, some people used to propel them to the roles of prophets. But the time passed, people start thinking about it and thought, hey, maybe we can use randomness to some other things. For example, for having some fun. Maybe you can start flipping the coins or rolling the dice. Maybe it would be fun. And apparently it was fun because we now have a huge gambling market. And back then, it was also simple way of having fun, also earning or losing the money. Other people thought, well, maybe we can go to the way and saying that some things happen because I predict that, and I think that this thing will be some kind of significant sign of something what will come. And that's how the divination came to life. People started to propel them as a fortune tellers and were saying things that they thought would happen based on some past actions, which seemed random, but in their eyes, in their words, they weren't. Then some more time passed. 17th century came. Mathematics was on the rise. There were many famous works of mathematicians, and they also worked on the topic of randomness or rather probability, because that was like a formal way of describing the randomness. These three gentlemen were the pure pioneers of the probability theory. They created it in the 17th century, and the theory is well usable for now. Then the 20th century came. People start thinking about where we can else use the random numbers. And apparently there are many places where these random numbers can be used. For example, in physics, biology, statistics, when we have to select random group of people for some kind of questionnaires or something. Or economy, where we're trying to find some trends. And also in computer science, there are many places where the random numbers are used. But we have to be careful when we are treating them and we are working with them, because many things rely on the random numbers and rely on the properties that this number is really random. It can't be predicted. And as we will see, some of the usages weren't correct. Random number can be generated two ways, which I described previously. So, for example, we can perform a physical action, for example, rolling a die or flipping a coin. It's random action. We can't predict what will be the result of this. The chances of getting each and every result should be equal. For example, if you are flipping a coin, the chance of getting heads should be 50%. But in reality, it's not always the case. Coin can be unequal. So maybe one side would be like elevated. Also, person who is flipping the coin may be doing it different way each time. So it may not be always 50-50. But for the purpose of flipping the coin and using it result, for example, I don't know, deciding which side of the field you will be playing, it's omittable. People accept that it's not perfect, but for the purpose of selecting one or two, it's fine. Also, we can get random number from software, from computer code created by people. And in this case, it's important to assure that this number generated by the code will be random. There will be no way to predict this. And computer doesn't know what does it mean to be random. It's only on the programmer side to assure that the code will be getting random results. Now we'll go to the random number generator, so the main topic of that. There are two ways of generating random numbers. They are called true and zero. I won't describe what are the differences right now. I go through both of them, and I think the difference will be obvious for you. First one, we'll go through the pseudo random number generators. The overall schema of the work which you are doing is like that. But first, we are selecting some number x0, then we are doing some calculations on that number, and the number x1 is our random number. If you want to get another random number, we go the same way, but as a starting point, we are using the result of the previous one. So we go x1 is our starting point, then we're doing the same calculations as is the first point, and then x2 is our second random number. Now let's go inside and see what kind of calculations we can do. The most classic one and the most, I think, easy to implement is this one. We are taking our number, we are multiplying it by some number, we are adding some other number, and we are taking the remainder of the division by m. And the result of this equation is our random number. Formal name of this operation is linear congruential generator, and is widely used as one of the easiest to implement and faster to execute generators. Each of these parameters has their own names. The first three are constant, so for each and every generated number they are the same. The only changing parameter is the axis. The names aren't that surprising. The m value is called modulus and has to be larger than 0, obviously. The a number is called multiplier and this has to be lower than m. And c is the increment and it also has to be lower than m. x0 value, so our starting point of the whole generating process is called traditionally seed, and it also has to be lower than m. Let's stay for a moment on the seed topic. Usually we are using some large number for seeds. The best way to do it is to use the Unix timestamp. For those of you who are not aware of this topic, the Unix timestamp is the number of seconds which has passed since January 1st, 1970. It was the classic way to determine what time is it in the system. Currently, as you can see, today's time, 2:50 p.m. is like 1.5 billion number. And it's constantly changing because it's 0, so 01 will be +1, this large number. It's a 32-bit integer. There's also a topic of ending of this number because 32 bits is not infinite, but it's a topic for another talk. This, as I said, these parameters are constant for each and every number, but they vary based on the source of this. For example, in C, programming language, M is to the power of 31, A is over 1 billion, and C is very clever 1, 2, 3, 4, 5. While in the Java, for example, the M is larger, it's 2 to the power of 48, A is over 2.5 billion, but C is only 11. So it's vary between the tools and programming languages, and this constant has to be selected very carefully, because not every combination of constants will give us random numbers or numbers that are treated by humans as random. IBM tried this also in the 1960s. They created their own random number generator called random, and the parameters were as follows. The multiplier was this number, which is 2 to the power 16 plus 3. Why not? C was 0, there is no plus there, and the modulus was 2 to the power of 31. Unfortunately, this combination of parameters gave not so random numbers. The numbers were from the sets of numbers, which were highly predictable. And Donald Knuth, one of the most famous computer scientists of the 20th century, said about this random number generator, it was truly horrible. So the meaning of that famous saying that something is truly horrible, I can't argue with that. The other thing we can do with the random number as a procedure to generate them is the procedure as follows. We're taking a 6-digit number, for example, if we want to generate a 6-digit random number, then we are squaring it, so we are taking it to the power of 2, and we are taking the 6 middle digits of this number, and this is our random number. It is also very easy to implement and gives very good random numbers. It's called mid-square method, obviously. There are many more operations that we can do to generate random numbers in this procedure. The most popular are bitwise operation or combination of bitwise operations, for example, excluding ORs or shifts, bitwise shifts left or right. There are also some methods that use interesting properties of prime numbers, which are apparently very useful in this case. And there are also modifications of the algorithm I showed in the beginnings of this linear convolutional generator. And there are some operations that were switched or changed, and we're also successful in getting the random numbers. And the true random number generators operates on the other processes. Instead of using the algorithm and the code to generate numbers, they are using the observations of physical phenomena. What phenomena? For example, they are measuring cosmic radiation. The radiation is coming from the outer space. The sensor is connected to the PC. The sensor is measuring some values, and the PC is changing these values to numbers. Also, there may be some methods of the thermal noise from the resistor or atmospheric noise from the atmosphere. It's all based on the same rule that we are attaching a sensor to the computer, and the sensor sends some data, and this data is processed treated as random numbers and changed to some random numbers from the some range. One of the things also is a clock drift. I will shortly describe what is a clock drift. In computers, the clocks that are used are quartz clocks, and they may be working on some different tick rates. For example, one clock is ticking 1 times per second, and the other clock is ticking 100,000 times per second. But this rate may vary. And this is not precise. It won't show the exact precise time at that moment, because it's very difficult to determine the exact time to the thousands of seconds. So clock drift is a difference between the current time and the time shown by the clock. And smart programmers find a way to change these differences into random numbers, because it's also changing. From the longer the clock is working, the more difference between actual time and the measured time is. So it's also very useful as a way of determining the random number. There are also other things that we can observe, which are happening in the computer. For example, time between the users pressing the buttons is hard to determine what user will press and how fast. Or, for example, what are the different time sticks for disks when you are reading some data? What are the times between each of the reads? It's also hard to determine how it works. The network is, so for example, how fast is the network, how many data is flowing through the network, etc. Mouse movements, it's also very hard to determine where the mouse will be and what will be the movements done. And also mobile phones, there are many sensors which readings can be used as a random number, for example, accelerometer, mic, camera, etc. Then I'd like to talk about some kinds on the topic of RNG manipulation. You may ask why you would like to do it. There may be some positive sides on getting the numbers which we want to. Unfortunately, some of the numbers are generated randomly, and we'd like to somehow manipulate them, determine what will be the exact result of the RNG. It's the one example that we'd like to show is connected to this console. It's Nintendo Entertainment System. It was created in 1983, and it was the source of many great games. For example, this game, Mega Man 2, it was a simple side-scrolling, well, it wasn't simple, but it was a side-scrolling platformer game, when your goal was to defeat these 8 enemies and then complete the game. It had one random number and one random thing, which I will talk about shortly. But when the game came out, its purpose wasn't to complete this game as fast as possible. It was just to complete the game and have fun. But then some time passes, and we have in the 2000s there is a race for a topic called speedrunning. Speedrunning is the way of playing the video games as fast as possible. So to complete them as fast as possible, people started to work on the games and see where are the minor changes to the gameplay that we can do to complete the games faster. And in the case of the Mega Man, there was one thing that was manipulated by RNG. And it was I can't remember what was that exactly, but the players determined that they can manipulate that number, and if they wouldn't manipulate, the times would be slower, so the times would be longer than they would like to have them. And they decided that they will try to manipulate them. It was done basically by the fact that the NES console didn't have the quartz clock in the inside. And how they determined the time which was passing, it wasn't just by the clock, but by the number of frames since the last launch of the console. So if we are resetting the console and stopping, for example, stopping its usage at the same time exactly, the same random number would be generated. So they decided to do this technique and they've achieved faster times than not manipulating this RNG number. I will also talk about some more manipulations later. Now let's go through the usages of the RNG. I've mentioned the gambling games. I think it's obvious that roulette games or slot machines are using random numbers, both as physical ones and virtual ones. Video games is also large source of random number usages, especially RPG games or some kind of games where you have equipment which is dropping from the enemies. It's all randomly generated, and people are trying to determine what are the chances of getting some valuable stuff. Statistics is also another source of random numbers. Like I mentioned, when we are selecting a group of people which should answer some questions, we should try to select them randomly, but in randomly controllable way. So, for example, the group should be representative from different ages or something like that. It depends on the types of statistics we are following. And also lotteries, when we are selecting numbers and telling them that these numbers are winners today. And also uses random numbers, mostly physical, but also virtual. The other usage is a sorting mechanism. I think you can go now and say, really, sorting? Sorting is like the completely opposite way of doing some random. It's getting from chaos to order. But apparently it is used in the algorithm of quicksort. It's one of the fastest algorithms known to exist. And it's basically a four-step mechanism. First, we are selecting the pivot, which is a number from the list we are trying to solve. Then we are moving the numbers around. So numbers smaller than the pivot are going to the left side of the array, and the number larger than the pivot are going to the right side of the array. Then we are using the same two steps to solve these L and R arrays. And if the lengths of the split arrays are length of 1, then they are restocking. And apparently, there are many tactics to select this pivot. We can select last number of the array. We can select middle number of the array, but and they are working just fine. But for the purpose of the analysis of the execution time of this algorithm, the best results was when we were selecting the random number, and the average times of the execution were the best with the random pivot. The last thing I'd like to talk is cryptography. The randomness here is used for generation, for example, for key generation. In the algorithms of PGP or RSA, the private and public keys are generated randomly, and they also have to be selected carefully. The other ones are nonces, which is the one-time random string sent from client to server to just authenticate yourself. And sols, which is also random number generated random string, which is generated and sometimes attached to the password which we are using, so it's harder to crack the password from the perspective of this hash. And also, not all random number generators can be used as cryptographic tools. They have to pass some very careful tests, and because that's where the security is dependent. So they can't allow themselves to have numbers which can be determined from some sources. Now I'll go through some random files. I already talked about the random stuff from IBM, which didn't work well. There was an issue in 2010 when the PS3 cryptography was cracked. The PS4 was working that when we inserting the original game, the disk drive, the game is scanning it for some kind of code which can be compared with the mechanical stuff inside the console, and the code was then decrypted, and the console could tell if the game inserted was original or not. But apparently, this mechanism wasn't so random. It was always the same code and always the the same task was performed. There was no random piece in there. However, the company was saying that it's random, it's always different. But apparently it wasn't. There were some guys that cracked this code and were able to open the PS3 console to the pirates so they could run their own pirated games. The last those two random files are connected to the lotteries. The first one is, I don't think it's, well, it's interesting. This guy, in 2015, he was working in the company who was operating this hot lotto lottery. And he was a security guy. He was one of the more important security guys at the company. And he manipulated the RNG used there, so he could precisely tell what numbers will be selected on which day. And apparently, he won a lot of money because of that, but his behavior was discovered in 2017, and he was pled guilty of his crimes. He had help from his brother, and he was convicted on 25 years, I think, in 2017. The second lottery scandal is, I think, more interesting. It happened in 1980 in Pennsylvania. The guy, who was called Nick Perry, was a presenter for this lottery, and he switched. It was classic lottery, like lotto. There was a ball with numbers, and the numbers were selected. And he switched two numbers from this ball, two balls with numbers, with balls number 4 and 6, to the larger ones. So the chances of getting there were higher, and he also determined which day the lottery will happen, and he won some large amount of money because the selection was 3 sixes. So that's the call, 666. He was also convicted for his crimes. Okay, so for the takeaway from this, most random numbers aren't really random, as we could tell. They are generated by a procedure, and if we can get into the procedure and set, for example, the seed, the number we would like to have, then we can determine what the numbers will be given as random. And there are many ways to generate random numbers. Most of them are easy to implement and quick to run, and some of them are more complicated but give more random results. And also, not every random number generator can be used in cryptography. As I said, it's really important to have these results really random, so there's no way to determine the results of the procedure. Have any questions? Okay, so thank you.
I can remind you that if you have any feedback, you can put it on the box. Thank you.